add some code to this. If you scroll down, it says additional methods will be added in later sections. This is the later section. The design pattern that we're going to employ today is called the visitor pattern. And it's a way that we can write one tree class and then extend that tree class, not like with a subclass extension, but extend the functionality of that tree class without writing a whole new tree class for any additional functionality we want. And we do this by by defining an interface, and we call that interface the visitor interface. So we're going to write this together right now. So we're going to write a java.comment to capture what this is. This is definitely a more advanced concept. The code is relatively straightforward. The concept's more advanced. A visitor whose visit method is called for each visited node during a tree traversal. Traversal? So public interface. So this is an interface inside of the tree class. We can do that. That's okay. It's like an inner class, but it's an interface. Visitor. And the visitor interface, visitor. I really want that to be capitalized. Why is it changing it on me? Has a single method. So let's write a java.comment for that. This method is called for each visited node. And there's one param, which is the data. And that's the data of the node being visited. So we'll say void visit. Again, we're not doing a parameterized type, so we just say object data like that. So the way this works conceptually is that we traverse a tree, and we could write methods to traverse that tree in pre-order, in order, or post-order. In a moment, we're going to write code to traverse it in pre-order. After that, you and your pair programming partner are going to do in order, I think. But whatever, we can have all the different traversals we want. But as we traverse the tree, for example, in pre-order, each time we get to a node, we're not going to like print it like we did on Thursday with our binary search tree. We're instead going to invoke the visit method on the visitor that is supplied to the tree traversal method. And that visit method can do whatever we want. It could calculate a sum, an average, a max, a min. It could print. It could store the data somewhere else. It's totally flexible, which is awesome. So let's make, this is very abstract. Let's make it more concrete. We're going to write we're outside of the visitor interface now. So we're going to write a pre-order public method. So we'll add a java.comment that says this method traverses this tree in pre-order. And it takes one parameter, v, which is the visitor to be invoked at each node. So here's what the method looks like. Public void pre-order visitor v. So now you can start to see how this pattern actually works. External code, some other code is going to build a tree, and on that tree invoke the pre-order method. And when it does invoke the pre-order method, it will pass a reference to a visitor. And that visitor is what then will have its visit method called at each node. This is a classic example of decoupling, keeping the analysis logic in the visitor and separate from the organizational logic in the tree. So this is cool. We're going to use one of these static recursive things to actually do this. So we're simply going to call the private static pre-order method on the tree, and we'll pass along the root as the node we are at, and we pass along the reference to the visitor because we'll need that as well. And then we'll document our static pre-order method that will be used recursively. This traverses the tree with a given root in pre-order. 2 parameters. N is the root of the tree to traverse, and V is the visitor to be invoked at each node. So private, static, we've written our recursive helper methods a lot in this unit. Preorder, 2 parameters. Cool. All right, and we will do this recursively, and we have to make sure we implement it in a preorder fashion. Let's start with our classic first question we ask: what is the easiest tree to visit in a pre-order fashion? That would be a tree that has no nodes. So if n is null, well, we're done. That's easy. We'll just say return. We have no work to do. That's our terminating condition. Pre-order says we visit the node first, and then we visit the entire left subtree, and then we visit the entire right subtree. So we need to do that. We need to visit the node first. So we're going to invoke the visit method on the specified visitor. Visit method on the specified visitor. And we pass along the data associated with the current node. Okay. That data could be a string. Maybe we're doing some analysis and we want to see what is the longest string in the tree. That data could be a number. Maybe we're calculating a mean or a max or a min. We don't know or care because of the genericness of the visitor. It can do whatever analysis we want, which is great. All right, after we visit the node, we then have to do all of the children. This is not a binary search tree. I know it's been a little while. This tree was a tree with an arbitrary number of children, just a list of children. So we're going to recursively invoke the preorder method on each of those children, okay? So we're gonna use an enhanced for loop here. So for child in children, and we'll invoke this preorder method, and we'll pass along the child and the same visitor. Oh, sorry, it's n.children, because n is the node. So we need that node's children. That's all it takes to do a preorder method. Not so bad. Okay. All right, let's see okay, great. Like how can we use this in a useful way? Let's go to traversal demo, the traversal demo class. Here we've already built up, we have code here to build up our tree with Ann, Peter, Zara, and Savannah. We've done that before. And then we have some commented out code here that we're going to enable. So I'm going to uncomment at the start and end here. This class called short name counter, it implements the visitor interface that is inside of the tree class. And what this class does is it has one instance variable, counter. It overrides the visit method, which it has to do because it implements the visitor interface. It prints the data. And then if the length of the string is less than or equal to 5, it increments a counter. Okay. So here's a whole class we wrote to be our custom analysis for the tree. Okay. Because we certainly don't want to write a whole new tree class just so we can write a method that counts how many short names are present in the tree. So the way we can use this is we create a new short name counter object right here. We assign that to the variable v. On the tree that we built, we invoke the preorder method. We pass along a reference to the visitor. When all is said and done, we then print out the counter, which will be how many short names exist in this tree. So less than or equal to 5, that should count Ann, Peter, and Zara, not Savannah. So we should get 3. And if we run this, sure enough, it prints them all out in preorder. And it says we have 3 short names. That's fantastic. That's just what we want. Okay. Writing this is a lot simpler than writing a whole new tree class. That's the power of the visitor pattern.